In this video, we are going to cover input binding. This is the action of loading up individual settings out of our config XML file and reading them in so that we can actually bind keys externally to the game itself.
That's right. And right now we've got kind of a temporary system to handle just a few keys. Now we're going to implement the rest of the system by which we can actually create key bindings in the XML file.
So let's jump right into the configuration file itself. We'll jump back into our content project and then jump down to config.xml, make sure we get that loaded up. So we'll give that just a second to load in. Now, for all of our inputs, we're actually going to take a slightly different approach to the configuration options we have used so far. Up until now, we have had each setting being represented by an individual node.
Mm-hmm.
In the case of our key bindings, we want to have a variable length list, if you will. We want the ability to have more or fewer bindings without having to specifically number them.
Okay.
So what we're going to do is we're going to make an entirely separate section inside of our config XML file, and we're going to call this section input. And inside of this input section, what we're going to do is put any number of nodes into it. And we're actually going to leave these nodes containing the exact same name. We're going to call these key bind nodes.
Okay.
So the idea is that inside of input, we'll have a series of key bind nodes, and then it's the attributes of those nodes that will describe the association between a device input and an internal game input.
All right.
Then inside of our game, we'll need to make a loading routine that is able to scan all of the nodes in the entire input section and load them all in one by one.
Okay. So they're going to be differentiated from each other by their attributes and not by their name.
Exactly. You can almost read this series of nodes as a series of commands.
Okay.
The idea is that we're essentially going to run the same command over and over again, but apply different pieces of data with that command.
All right.
So we'll type out a few of these entries and it should begin to make a little bit more sense. So the way these are going to work is each command, if you will be an individual node. So we'll start off and we'll call the node keybind. Then we'll set up a series of attributes. Now the things that we're going to need for any given device input binding are an input port, a device input name, a game input name, a player field, and a data field.
Okay. Now, as you put each one of these in, why don't you briefly describe what its purpose is going to be?
All right, let's begin with port. We'll drop in an attribute called port, and we'll set it to 0 in the case of keyboard input.
Okay. Now, what's that port going to do?
In key bindings, absolutely nothing. When we get into devices, types of devices where you may have more than one of that device hooked up.
Such as two gamepads?
Exactly. Such as a gamepad where you can have up to 4 devices.
Okay.
The idea is that port is going to allow us to address a specific device.
All right.
So if you had 2 gamepads that you were binding, one would be port 0 and the other would be port 1.
But in the case of the keyboard, it's not significant, though it is required to have in here.
Right. The idea is that this format, this series of fields, is going to be the same for every kind of input throughout our game. Keyboard input, gamepad input, drum input. We're going to use the same format, and that will allow us to use the same routine to pull in all of our bindings and save on code reuse.
Okay.
But that does mean that in certain cases, some of these fields may seem redundant.
Mm-hmm.
For example, in the case of port with the keyboard. But really, it does keep everything a lot more unified in the end.
Sure.
All right, moving on, we have the second field, which is going to be an attribute called device input. And we'll set the first device input to enter.
Now, this is the equivalent of whatever input is coming in actually from the keyboard prior to translation by our input class.
Right. This is the device side of the communication.
Mm-hmm.
In the case of keyboard input, this is going to be in terms of the keys enumeration, just like we had done inside of the keyboard input class where we were looking at the various things found in that keys enumeration. The value placed here into device input is going to be the actual textual name of each of those enumeration elements.
Okay.
So in this case, if we were to look through the keys enumeration, one of the keys listed there would be enter. All right, the next attribute will be game input. And we'll set the first one here to select. Now, game input is the other side of the translation.
This is what the game actually sees.
Right. This is what we're setting up so that whenever the enter button is pressed on the device input, internally the game will see select. So really this is the core of where binding takes place.
Right.
By placing device input next to game input, we're saying bind enter from the device to select inside of the game.
Gotcha.
Alright, next up we have the player attribute. And we'll set the first one here equal to 0. Now, as we're putting together our device inputs, we're going to give the ability to bind each individual button from any of our devices to be respective of a certain player. And that way we could say that the buttons from Gamepad 1 might bind to player 1. The buttons from Gamepad 2 might bind to player 2.
Okay.
The one thing to keep in mind is that these values are 0-based. So that means
player 1 is actually 0.
That's right. So you have players 0 through 3 in the case of a gamepad.
Okay.
All right, we have one more attribute to address, and that is data. Once again, we'll set data equal to 0 for our first attribute here.
Now, everything else has been fairly descriptive in its name. Data is kind of ambiguous, so what's that passing along?
Data, in this case, is meant to be dependent on the type of input. In the case of things like select, up and down and back, data is not actually going to do anything. It's not even really going to be considered by the end code that's going to use these inputs. Data is meant to be generic and ambiguous at this level, but it takes on meaning when it's used in conjunction with certain inputs.
Such as?
When we get into using notes. If you remember, inside of our input class, as a matter of fact, if we jump over to input, you'll remember that named inputs consist of a series of inputs, but we gave ourselves only one button for any given note. And we know right off the bat that we're going to have more than one kind of note. We're going to have different tracks that will represent different drums. And the idea is that data is going to be used in conjunction with the internal game input, so we can assign additional meaning to those.
So could you look at it as data being kind of a modifier for your game input? So that where you have like select, which is always going to have data 0, because at that point, who really cares about the data? However, when you get down to playing notes, you can use data to differentiate between the different types of notes you play. So you're sending in note, but you're kind of modifying it by adding some data to it so that you know the difference between note 0, note 1, note 2, note 3, and so on.
And then you could kind of read, maybe you could read the hi-hat as being input note modifier 1.
Gotcha.
And you could read the snare as input note modifier 2.
So which is where you were saying this is going to be treated kind of like a numbered list.
Exactly. This is once again another case of that. So we'll have input entries that are a series of node inputs one after another.
Okay.
And then their individual meaning is given by that additional modifier in the form of data.
But for unique game inputs, things like back, up, down, left, right, reset, you don't really need to send it any data because you don't have another version of that that command, if you will.
Right. Back is never going to be used for anything other than back. There's not like a different form of back.
Okay.
All right. And that's all of the attributes that are going to go along with any given input binding command. So we are going to end off this keybind node, and now we need to add some additional key bindings. Let's begin with the second one. In the end, we'll probably just duplicate a lot of these off and drop the names in place. We'll duplicate one more just to get an idea of the command nature of these. The next input that we're going to bind is where we will take the escape key and bind that to the internal input back. So as far as the association goes, it's a simple matter of taking device input of escape and game input of back, and player and data are both going to be 0. And now you will note that the node name is exactly the same.
Sure.
Which means we will have to take this into special consideration to get all these nodes loaded out, since we can't just address config/input/keybind, because the idea here is, well, which one?
Yeah, they don't have unique names like keybind 0, keybind 1, keybind 2, and so on.
Right, but because we are given the necessary facilities to look at the entire input section and get any and every node out of it, regardless of what its name is.
Well, in the end, we're going to need all of them. It's not like you're just going to need some of the bindings and not others.
Right, so we will have the facilities available to us to get all of the key binding nodes and which is kind of helpful because the idea is that we can actually put different kinds of binding nodes. We could put key bind nodes right next to gamepad bind nodes, and then later in code we can loop through all of the nodes, regardless of what they are.
As long as they're under input.
Right, as long as they're under input, and then say that, oh, we got a key bind, excellent, bind that to the keyboard. We got another key bind, excellent, bind that to the keyboard. And then later in time, oh, we got a gamepad, bind that to the gamepad.
Gotcha. Very cool.
So, let's see. We need to do maybe another one of those template copy and duplicate scenarios. So we'll grab one more line. I'll drop in temp and temp into device input and game input.
Would it be cheating if I told you I thought you needed about 13 more of those? Actually 12 now.
It would be, but it would actually be rather helpful cheating.
I think it's 12 from this point on.
Alright, let's see. And that's 12. That should get us close anyway. And we can simply go down the list now and set up all of the binding associations we'd like to put in. So, after escape, the next thing we're going to bind is the up key. So, in this case, the up element in the keys enumeration is named the same as the up element in the game, the named inputs enumeration.
Okay.
So we're simply binding up to up.
Fair enough.
And this is the same for all of the directional inputs.
So down becomes down, left becomes left, right becomes right, unless you want to reverse those two just to mess with your player.
Yep. Exactly. So you do have the ability to reverse whatever you'd like. In this case, there's no...
It's not like a flight sim, so you don't want to do that.
Right, so it's used only for menu type stuff. So up, down, right, binds to right.
Never could understand that. Like first-person shooters, people who like reverse controls, I can't get into it.
Yeah, I guess it's just all on how you learn it.
Yeah,
it's like if you've
how
got
your brain works.
And let's see. So there's all of our directions, and then one
After
more.
left comes space, which is bound to reset. Now it looks like everything else that you have here is going to be bound to note, and this is where data is going to start coming into play. The first one is Z, which is bound to note.
So here's the first of our notes. The idea for keyboard notes is we're going to take keys starting at the Z key, working our way right to go across the staff. So basically we'll have Z set to crash, X set to hi-hat, C set to snare, so on until we get to the bottom, which is going to be which is actually going to be crash. So
Assuming you've got a standard QWERTY keyboard.
Exactly. So in that case, you may want to change the bindings. The idea is we're using the bottom row of keys to represent different drums.
And just get a stack of keys that are all right next to each other. It doesn't matter which ones you use.
So starting at Z, we'll bind that to a game input of note. Player will be 0, and data is actually still going to be 0 since it is the first track. And once again, we're dealing with a 0-based set of numbers.
Okay.
So we'll actually say that Z is bound to note 0.
But from here on out, anytime we have a game input of note, we're going to start updating data to accommodate the next note.
Right. So if we move on to the next key, which is X in our case, we'll bind that to note as well. So just looking at these associations, it looks like Z and X are bound to the same thing.
Right. And this is where I was saying that you could kind of look at the data area as kind of like a modifier.
Right, because in this case, in order to differentiate between X and Z, the part that becomes different is the fact that data is going to be looking at track 1. So that means inside of the game, when we're reading note inputs, we will also take into account data, and we'll map data to a specific track.
Gotcha.
And that way, X is note track 0, or excuse me, Z is note track 0, X is note track 1. So now we can simply work our way across the keyboard to bind the C key to a note, player 0, track 2, or rather data 2. The V key will be bound to note, data 3. The B key will be bound to note, data 4. The N key will be bound to note, data 5. And let's see, next up we have the M key, bound to note data 6, and we need one more. Looking into the future, we know that we're going to have one more track along our game to finish out the crash sound, and that's actually going to be an 8th track, or in this case 0 bass, that would be track 7.
Okay.
And we've run out of keys in the bottom of our keyboard. And the next key we have next to
We've
M...
run out of letters anyway.
Oh, yeah, exactly, and as far as horizontal is concerned. And the key sitting to the right of M is the comma key. Now, in the case of the keys enumeration, one question that comes up when you're going through all these keys is certain ones make sense. Like all of the letters, those are obvious. You just drop the name in. Some of the other ones, like maybe some of the plus and minus keys, some of the numpad keys, you might be wondering exactly where do you get the specific name for each of these keys.
Mm-hmm.
So in order to find, because I mean it seems like, well, that would just be comma, so we would type comma here.
Right.
That doesn't necessarily work. What I want to do is very briefly jump into keyboard input just so I can gain easy access to a keys enumeration. Right click on it and go to definition.
Mm-hmm.
Just so we can jump in and look for comma. And let's see. Comma does occur, but it's actually called OEM comma.
Okay.
So that means the name that we have to put here is OEM comma. So back in here. So you might want to keep that in mind if you're going through all of your inputs and wondering why certain ones that make sense aren't working. In this case, we needed some way of magically knowing that this was OEM comma.
Now this may seem like a perfectly ridiculous question, but does this system care whether or not you specify a capital or lowercase letter?
That depends on the way we write the code that comes after this.
Okay.
The way we're going to implement it should not care about casing.
Okay. Just curious.
In the end, you can actually make it represent either way,
Mm-hmm.
but in our case, we're going to make it case insensitive.
Okay.
One last thing I do want to do, just to make this a little bit easier to read, is I'm going to space these out so that we form nice table-style columns.
Okay. It'll be a little easier to read. I don't suppose tabbing works well in here, does it?
It depends on what mood Visual Studio's in. The idea there, yeah, like that one didn't. It'll get us close.
It's like a set number of spaces in this case. Good old Unicode tabbing.
So again, this is just a matter of taste, really. But it does make it somewhat easier to read through the file.
Sure.
If everything is lined up nicely.
Well, you can real quickly see the device input enter attaches to game input select. So.
And then once we start getting into different devices, it is nice to have everything
Sure.
lining up. Alright, so again, that just gets things a bit cleaned up there. And one thing, even though I mentioned that this last track was going to be data 7, apparently that got missed when we duplicated it, so we'll make sure that that gets corrected there.
No problem.
So we have data 0 through 7 representing our different notes. We have all of our inputs. We've even looked up how we get more oddly named keys like OEM comma. And so let's go ahead and make sure we save out our config XML file.
And at this point, we've wrapped up all the code we need to add to the XML file, yeah?
Yes, so this is everything we need before we jump in and write the reading code.
Okay, well, let's go ahead and do that in the next video.